Hello, welcome to part 10 of a Great Cow Basic tutorial. Today we're looking at the Logic Green Technologies LGT8XM chipset, and we're focusing today on using I2C. Today I'm going to be using the GLCD to represent the capabilities of I2C on these chipsets. Well, we're making our way through the tutorials. We're on about lab 13 now, and we're going to cover two items today with respect to I2C. You've seen this before. This is what the board looks like. They're readily available. They come as chips direct from the manufacturer or on PCBs. I'm going to be using the green one. Well, the board itself has many connectivity options, and I will be using I2C today. We have gone through many of the items on the screen here in terms of the blue outer boxes, and we've been through those. Let me just put it on. We've been through a number of these here in terms of connecting LEDs and resistors, and yesterday we went through, on the previous, we went through another set of resistors here, and over on the left-hand side to use pulse width modulation. But today we're going to be focusing on these two items here, which is I2C. Let me zoom in on there so we can talk about it a bit more. Essentially, I have got the GLCD connected into these two lines here, A5 and A4, and they are respectively the clock line for I2C and the data line for I2C. And I pulled them high with a 4K resistor because I'm doing that for good practice. I don't need to do that because the GLCD driver I'm using has those fitted, but I fitted them for today. These data lines are sometimes called SDA, and the clock line is called SCL. And we will just have a couple of constants to set them up, and once we've set them up, then I2C is operational. Let's have a look out in the lab. This is the actual GLCD connected. I'm going to show you a layout in a moment, but I've got it connected beneath here, and you can see there are four connections in here. One is a VCC, one is ground, one is SCL or clock, and SDA, that is the data. And you can see that the thing is live. Underneath here, it is the same board, I guarantee you. What does that look like? It looks like this in terms of the LGT board pressed into that breadboard. I've connected in a data line here on A4 out to the data connection here, and then I've connected the clock line in on A5 to the clock connector. I've also got connected in a ground or 0 volts and a supply of 5 volts. When you do yours, please ensure you select the correct voltage. So what are we going to look at? We're going to look at this particular GLCD. Could be any of the others that use I2C, also known as TWI, but this one happens to be a 128 by 64, very bright in actual fact, and as I said, it needs to have those kind of connectivities. So we're looking at this very simple BMP example here. Then I'm going to show you how to do I2 discovery in Great Cow Basic, and then we'll have a quick look at the primitives. So how do we go about putting a BMP in it? Well, what we need is a picture. We start with a picture. This is my picture here. I'm having to rotate it 180 degrees purely for the camera, which is a bit annoying, but never mind. Let me just mark this. I'm just going to take that out, and I'm just going to show you how easy it is to actually edit in here. I just cut the bottom of my chin off. This is my logo or my avatar. I'll delete that. I'm just going to put some text in there. If I take the chip name, that'd be quite a good thing to have on the screen. I've just taken it from the editor. I'm just going to paste it into here in the text box. As you can't see that, it would help if I showed you my desktop. There we go, my desktop. I'm in BMP. I've just opened up the file, which I'll show you how to do that in a moment. And here we have LGT, the actual chip on here. I'm just going to rotate that around for us by 180 degrees and save it. And then in my program, which I've got here for you, we can see how we then import that in. Because we can see it says Anobium. How do we make it so that it actually imports it in? Well, we set up the chip at option explicit. We've seen that before. We tell it the GLCD type, and that's this constant here. It's a constant, and the address of the I2C. GLCD I2C underscore address. Then we include a couple of includes. One is include the graphics library, GLCD.H, and then you can use the same include line to convert BMPs, JPEGs, and other items that you want to import inside a Great Cow Basic. There may be a converter being built for you. There is one for the BMP, and we're going to take advantage of that. Then we set up the I2C with 3 defines, one for the baud rate, one for the data line, one for the clock line, and then we tell it with a function, or a method actually, I2 mode. It's a master device, and all I'm doing is telling it in the constants the frequency and the 2 ports. Once I've done that, I can call a method called draw my BMP, and it will draw it on the screen. As you can see, it's converted it for us, and it's displayed it on the screen for us as it's compiling it. You can turn that off. I turned it on so that we could see it today. It's now compiling the program up. It is a larger program because we're doing it dynamically. If you've already written the converter, then you don't need to do it, and it is a lot faster. Here we have it. It's upside down. Now, why is that upside down? It's because I converted it inside of here, which I will just flip back for us on my desktop. Zoom, rotate by 180, save it, and reload it. But as you can see, that is extremely simple to do. And now it's scrolling it, and it's just finished programming it. No, it's just about to finish programming it. There we go, it's the right way around now, which is excellent. Look at that. It's now scrolling. We're using the hardware features within the graphics device to do some clever stuff. So you can load BMPs with great ease. However, we happen to know the address of this device. It was address 0 is in hex 78. Well, sometimes that's not so easy to find, and so we have a utility that it does exactly the same, and this is part of our standard install, so you don't have to go hunting around for it. We're going to output the little diagram of the values of discovered devices on the bus through a terminal. So let's just flash that in there to start with, and then we'll look at the result and then explain it. So it's loaded it in. Now it's loaded it in, which is quite good. And I'm just going to bring a terminal into here. I'm going to push that button, and on the screen, I'll do that again. I brought it in on the screen. I'll just clear that down for us. We get a display of the bus. What we've got here are 2 devices, the 2 devices, the read and write devices for our GLCD device. It matches up with what we expect. And this is explicit for the I2C devices, but it shows you as many devices you've got listed on the bus, what those addresses are, then you can actually talk to them. It's a great tool, and you should always start all your I2C with this discovery program. And we include that as part of the portfolio of software. So let's go back. We've got our bouncing logo here. What else can we do inside of Great Cow Basic? Well, as I said in the introduction, we can do some primitives in here, and I'll just show you how to do those primitives. I'm just going to comment those 2 out because I've actually got them in my program down here, and here they are, set of primitives, and those primitives are going to be lines and etc. So let's just stop the conversion of that BMP. I don't want to be doing that anymore, and I'll just load those primitives in so that we can see it. It's compiling the program up. Didn't do the conversion, which is quite correct. Now you can see you've got circles, squares, text, etc. And we have different size fonts and different fonts, etc. And you can even write your own fonts if you're up to that. But they're all the same across the whole portfolio of GLCD devices. So if you want to print a string, you can say GLCD print an X and Y location on the screen and the word print screen. You can then output other values, and as you can see, there's many different highlighted GLCD prints, and you will see that you'll get all have a number of parameters like X position, Y position, the actual type, and this can be a string, a constant, a number, long number, a word number, a byte number, depends what you want to do. And as you can see, you've got circles, etc. And you've got quite an extensive capability within Great Cow Basic on these primitives. From that, you should be able to build a lot of capability. So this is just indexing through, drawing out numbers, etc. to show us what the capabilities are. If I reset the chip, you can see it's got a full font set from ASCII 32 to 127 built in. You've also got 128 to 255 for other international languages as well, but that uses a slightly larger amount of RAM. This particular LCD can use only requires a few bytes to actually work. About I think it might need 16 bytes to work in its minimum mode. This is actually using about 1K of RAM, but you can get that down to very few bytes of memory. So what I wanted to show you is I2C. It's extremely simple. You set it up, as we saw previously, with a number of constants, and once those constants are set up, then you've got the bus available to you. This is the constants for I2C, baud, data, and clock, and then you tell it it's a master. That is I2C set up, and after that, you can then use that within your own programs as well, using things like stop, start, send, receive, etc. All very simple and pretty easy to use in the program. So I wanted to show you that, done it, and enjoy.